So you're building something in the cloud. You're pretty much always going to need a database. But here's the thing. Managing one can feel like a complete full-time job on its own. Today, we're going to pull back the curtain on one of the most foundational services in all of AWS, Amazon RDS, the Relational Database Service. Let's get right into it. I mean, really think about that for a second. When you manage a database the old-fashioned way, there's just so much grunt work. It's endless. But what if you could just hand all of that off? What if you had a dedicated, tireless butler for your data who handled all the boring stuff so you could focus on what you actually care about, your application? Before we get to the solution, our fancy cloud butler, let's really dig into the problem. We'll call it the database headache. These are all the things that you're stuck worrying about when you decide to manage a database all by yourself. Now look at this list. You see something pretty interesting, right? None of these tasks have anything to do with your actual app. This is all what the pros call undifferentiated heavy lifting. You're stuck patching operating systems, wondering if a server's hard drive is about to die, installing database software, wrestling with backup scripts. It's not just a pain, it's risky, it eats up all your time, and it pulls you away from building cool new features. And this is where our cloud butler, Amazon RDS, comes into the picture. It's built from the ground up to take that entire headache away by automating all that administration so you can get back to doing your actual job. This right here is the heart of it. It's called the shared responsibility model. Over on the left, you see all the messy infrastructure stuff that AWS just handles for you. The patching, the backups, the hardware failures, poof, gone. And that frees you up to focus on the high-value work over on the right, making your queries run faster, tuning your database indexes for peak performance, and, most importantly, managing the security and integrity of your actual data. And you're not getting locked into just one technology either. RDS gives you a ton of flexibility. It supports 6 different database engines. Everything from popular open-source options like MySQL and Postgres to the big commercial players like Oracle and SQL Server. This is a huge deal, especially if you're trying to move an older existing application into the cloud without having to rewrite the whole thing. Okay, now we are getting to the absolute core of designing with RDS. This is the part that trips up so many people, especially on certification exams. It all comes down to one central conflict every database architect faces. Are you trying to survive a disaster, or are you trying to scale for a flood of users? And this is the key takeaway, the one thing you really need to burn into your memory. The tools you use for disaster recovery and fault tolerance are completely different from the tools you use for speed and performance. Trying to solve one problem with the other's tool is a recipe for failure. It's a classic mistake. Let's really break this table down because it's so important. On the left, you have multi-AZ. The best way to think of this is like a stunt double for your database. It's an exact, perfect copy that's updated synchronously, meaning every single write is confirmed on both. It just sits there passively in a different physical location or availability zone. If your main database goes down, bam, AWS automatically flips traffic over to the stunt double, and your app never even knows anything happened. Now, over on the right, you have read replicas. These are totally different. Think of them like photocopies. They are active, read-only copies of your database that you can send all your select queries to. The copying is asynchronous, so there might be a tiny bit of lag, but it's what lets you handle massive amounts of read traffic, even spreading it across the globe. All right, enough with the theory. Theory is great, but let's see how this stuff actually works in the real world. We're going to do a few rapid-fire puzzles, kind of like what you'd see in an exam, to really make these concepts stick. Okay, first puzzle. Imagine you have a super popular blog. Tons of people are reading your articles, which means a massive amount of select queries are hitting your database. But very few people are writing new comments. The database is getting totally bogged down with all the read requests, and the whole site is slowing to a crawl. What do? Yep, the answer comes straight from our table. This is a classic scalability problem, right? Not a disaster recovery problem. So the solution is to create those photocopies, one or more read replicas. You then point all that read traffic to them, which completely frees up your main database to handle the important job of writing new data. Here's a more modern problem, one that's super common with serverless apps. You've got an AWS Lambda function that can spin up thousands of copies of itself in seconds. And every single one of those copies tries to open a new connection to your database. Your database just can't handle it, gets overwhelmed, and starts throwing too many connections errors. How do you fix it? For this, you need a middleman. You need Amazon RDS Proxy. It's a service that sits between your Lambda functions and your database. It keeps a warm pool of database connections ready to go and intelligently shares them among all your function invocations. Your functions talk to the proxy talks to the database, and the connection storm just goes away. It's pretty much essential if you want serverless and relational databases to be friends.
This is a classic gotcha question. Let's say you spun up a database for a quick test, you didn't bother checking the encryption box, and now suddenly that database needs to be used in production and has to be secure. You can't just go into the settings and flip a switch on the running database. So, now what? You have to do this little three-step dance that I like to call the encryption shuffle. First, you take a snapshot of your unencrypted database. Simple enough. Step 2, you make a copy of that snapshot, and it's during this copy process that you'll see a little checkbox to enable encryption. Then, for the final step, you restore a totally new database from that new encrypted snapshot. It's a few hoops to jump through, but it's the only way to do it. Okay, last puzzle, and this one's a bit of a curveball. Your application has a very weird specific requirement. It needs some custom plugin installed on the database server, and to do that, you need to SSHN and get root access to the underlying operating system. Can you still use our friendly cloud butler, RDS? And the answer is a hard no. This really gets to the fundamental trade-off of a managed service. The whole point of RDS is that AWS handles the OS for you, which means they can't let you touch it. If you absolutely need that low-level control, you have to give up the butler and go back to the old way. Spin up a plain, easy-to virtual server and install, configure, and manage the database yourself. So we've seen how RDS is this amazing database butler, right? It handles your backups, your patching, your scaling, your disaster recovery. It is an incredibly powerful tool. But that brings us to one final critical thought. With all of that automation, what is the one incredibly important thing that RDS can never, ever do for you? Well, it can't write your application's code. It can't optimize your queries. It can't understand your data model. That stuff, that's still on you.